All right, so we've got another quadrilateral to classify. Again, first step, always make sure that you plot the quadrilateral and then connect the vertices. The second step, use the distance formula to figure out the lengths of the sides. So we're going to figure out what's the distance from A to B. Again, you want to use your distance formula here. So -5, so difference of the x's, squared, plus the differences of the y's, squared. Simplify that. We get -4 squared plus 1 squared. 16 plus 1 is 17. Final answer is square root of 17. So that means that AB is the distance square root of 17. Next thing, I like to go to the opposite side, so I find out what's the distance from C to D. Again, using the distance formula, differences of the x's squared plus the differences of the y's squared. I'm going to use a calculator here to simplify it. Turns out I get the square root of 65. Next thing is find out the other two sides. So A to D, using the distance formula, -5 subtract -4 squared plus 5 subtract 1 squared. Turns out we end up with the square root of 17. And the last side, BC, using that distance formula, -1 subtract 3 squared plus 4 subtract -3 squared. Turns out we end up with an answer of square root of 65. So when we take a look at this, our opposite sides aren't equal to each other. So parallelogram is out. Well, if it's not a parallelogram, it can't be a rhombus, rectangle, or a square. So we have to figure out, is it a trapezoid or a kite? And if we look carefully, we do have two distinct sets of equal and adjacent sides. When you take a look, square root of 17 is next to square root of 17, and square root of 65 is next to square root of 65. So therefore, ABCD is a kite.